Hello chemists, right, today we're going to be looking at reversible reactions from the AQA chemistry spec. So let's get started. So a reversible reaction is a reaction where reactants can be converted into products, and then the products of that reaction could be converted back into the reactants. This is an important definition for a reversible reaction, and it's very important that you do use the terms reactants and products when describing one of these reactions. Also, we use this arrow, as you can see here, in the middle of the equation, and if you see one of those arrows, then you know the reaction that you're looking at is reversible. Now, before we move on, it's important to recap the different types of energy transfer that can exist in a chemical reaction. There are two types of energy transfer that we study at GCSE. The first is an exothermic reaction, and the second is an endothermic reaction. Just a quick recap on these definitions. So an exothermic reaction is one that releases heat energy to the surroundings, and that causes the surrounding temperature to increase. An endothermic reaction is one that absorbs heat energy from the surroundings, so the surrounding temperature is going to decrease. Now we can apply these to reversible reactions. So if the energy transfer is exothermic in the forwards direction, that means if reactants are turning into products, then we can infer that this energy transfer will be endothermic in the reverse direction. In other words, if it releases heat when it goes forwards, then it'll absorb heat if it goes backwards. So exo and endo. You never know which direction is going to be endo or exo unless you have experimental evidence, but they will always be endo in one direction, exo in the other. So in this example, the forwards reaction is exothermic, and that means in this case it released 300 joules of energy. So that means the reverse reaction will be endothermic, but it will absorb the same amount of energy as was released in the forwards direction. So this one will absorb 300 joules of energy. You'll notice I've put a minus sign on the exothermic in terms of releasing energy. That's because we're looking at the chemicals themselves. They've lost energy as such as they've been converted into products. So that's why actually the release of energy is shown as a negative number. If you think about a reaction profile, the graphs, the arrow is always going down like a negative, okay? Or bond energy calculations, you always end up with a negative number for exothermic reactions. So it's important that these energy values are exactly the same, but they are opposite because we've got the exo and then the endo. Okay, so we can change the direction of an endo or exothermic reaction. And I'm going to look at the most common example today, which is the use of hydrated copper sulfate. Now, hydrated copper sulfate has this formula over here, CuSO4, so there's the copper sulfate bit, and because it's hydrated, it essentially means we've got water bonded to it. So we use this little dot symbol here, which is what we call water of crystallization. So that water there is not liquid water, it's actually incorporated into this solid hydrated copper sulfate substance here. You can stick basically 5 water molecules around a copper sulfate molecule, and that's all of a solid, and it's a blue colour. Okay, so it's a blue colour. And actually, if we heat this substance up, it will thermally decompose, and the water will separate away from the copper sulfate. And for that reason, we end up with this white compound here, which is called anhydrous copper sulfate, CuSO4. Anhydrous means no water, it's without water. And then the water separates from it, so we get that 5H2O separate. Now, if we added water back to this anhydrous copper sulfate, it would change back to this blue hydrated copper sulfate, so we can reverse the reaction. So here's a reaction equation here. Here's the hydrated copper sulfate here, which is blue. If we heated that up, it would form the anhydrous copper sulfate here, white, and water. Okay. Now, because we're heating this reaction up to make it go forwards, that actually means it's endothermic, because if you heat a reaction up, it means it wants to absorb heat. So the forwards reaction here is endothermic. And as I said, we get this colour change from the blue hydrated copper sulfate to the white anhydrous copper sulfate. Now this means that if it's endothermic in the forwards direction, we're heating it up so it can absorb that heat energy, then it's actually exothermic in the reverse direction. So if we were to go backwards, it would actually release a bit of heat energy and you might feel it warm up the surroundings around you. But actually the way to make this reaction reverse is to actually add that water back to the anhydrous copper sulfate. So let's have a look at how we would do this practically. I've put the information above just for reference. So here's an example of the diagram that you could draw for this reaction. So we've got a boiling tube here, and connected up to this boiling tube we've got a delivery tube, and the delivery tube is poked into a test tube, and you can see that this test tube is sitting in an ice water bath. Okay, so essentially what we're going to do is we're going to heat up our hydrated copper sulfate inside this boiling tube using a Bunsen burner. And as we heat it up, it's going to give off this water, but because you've heated it so much, the water is going to essentially come off as steam. So by passing that steam down this delivery tube, it will collect in the test tube here. But to stop it all evaporating out the top of the test tube, we've surrounded the test tube with an ice bath, and that will make the sides of the test tube cold, so any water vapor or steam that touches that test tube will instantly condense into water. Liquid water, that is, and it will collect on the inside of this test tube here without evaporating off. The hydrated copper sulfate, well, because it's releasing that water, it's turning into anhydrous copper sulfate, so we'll see this here change from blue to white. Then if we were to take this water that's collected in the test tube and add it back to this white anhydrous copper sulfate, once it's turned white that is, then it will change back to blue. Here's an example of the method for this reaction. I'd weigh a certain quantity of mass of the hydrated copper sulfate using a balance, and I'd transfer it to the boiling tube. I'd connect the delivery tube with the end into a test tube which is surrounded with icy water to aid the condensation of water collected. Then I'd heat the hydrated copper sulfate using a Bunsen burner. I'd observe a colour change from blue to white. The water would collect in the test tube, and then I could use a pipette to add this water back to the white anhydrous copper sulfate, and I should get a colour change from white back to blue. Okay, so that's pretty much a summary of reversible reactions for GCSE chemistry. I hope you found that useful. If you could have a go at the exam questions that I've attached to your Google Classroom, or if you're just watching this video for fun, then make sure you do some exam practice. Thanks very much.